So before we move on to rational exponents, the new topic for today, I wanted to do a few problems from last night's practice to help you out with negative exponents, exponents of 0, and dividing bases. If we start with number 2, number 2 is 3n to the power of 0 times 4n. Right here, n raised to the power of 0, that's equal to 1. And when you multiply things by 1, nothing changes. So it's essentially, you're able to cross that out and not worry about it anymore. So you're left with 3 times 4 times n. And from here, there's no other n base to combine n with, and you can multiply 3 times 4 and get 12. And 12n is your final answer. Number 4, you have a power raised to a power, and when you have that, you multiply the powers together. So negative 1 times 3 is negative 3. And we don't want to leave this as a negative exponent. When we have a negative exponent, we're going to take the reciprocal of what the base is right now. So right now, it's on top of a fraction over 1, and we want to change that to 1 over b to the power of 3. Once you move the base from the top to the bottom, the power becomes positive. And this is it for that problem. Look to number 6. You have m to the negative 4th over 2 times m to the negative 2nd. You have a pair of bases of m that are being divided, so you're going to subtract the exponents. 2 is going to remain down below in the denominator. When you do m to the negative 4th minus a negative 2, what actually happens here is you're doing m to the negative 4th plus 2. So we subtract a negative. So what you get is m to the negative 2nd as a result. Now we don't want negative exponents in our answer, so we want to move this base and exponent. So right now it's on top, so it's going to go to the bottom. Remember, once you move it, the power becomes positive. You may be thinking to yourself, what goes in the numerator now that I've moved the m to the negative 2nd power? Well, in case you forgot, there is a 1 sitting in front of this m that we don't have to write because we assume it is there. That is now what goes on top. So that is your final answer. Number 8, you have a pair of n bases being divided, and we subtract exponents when we divide bases. 4 minus 4 is 0, and n to the power of 0, we've all talked about, is equal to 1. So it's something we can actually cross out because multiplying by 1 doesn't change anything. So what's left? We have 4m to the 2nd on the bottom. And on top, there again was that imaginary 1 that was sitting there, but we don't write it because we assume it is there. We're going to write that down in the numerator. And this ends up being the final answer. Number 10, you have 1, 2, 3 factors inside a set of parentheses, all raised to the power of negative 1. So you guys are going to, not using the word distribute, but apply the power of negative 1 to all 3 factors. So it's going to be 3 to the power of negative 1, x to the negative 3rd to the power of negative 1, and y to the 3rd to the power of negative 1. Power raised to a power means you're going to multiply. Negative 3 times a negative 1 is a positive 3. Positive 3 times a negative 1 to the power of y is a negative 3. So we have 3 factors now, 2 of which are negative exponents. That means those 2 will be moving for the reciprocals. I'm going to rewrite this over here. On the bottom, we'll go 3 and y to the 3rd, because both of those were negative exponents, so they need to be moved. X to the third, however, is a positive exponent. That doesn't need to go anywhere. It can stay right there in the numerator. All exponents are positive, therefore you are done with this problem. The final problem, number 16, you have two factors in the inside set of the parentheses, all raised to the power of negative 4. Again, you're going to apply this power of negative 4 to both terms. So it's going to be y to the negative 4th to the negative 4th. Over here, you have 0 to the 0th power. So this is 1. So even if I raise to the power of negative 4, it's still going to be 1. So this ends up being just 1. We don't have to do anything else with it. We can just kind of cross it out and forget about it. This one here, negative 4 raised to negative 4, that's positive 16 when you multiply them. All exponents are positive, and we are done with that problem.